Okay, now we'll be talking about naming of compounds, naming of organic compounds. Now, before we name organic compounds, we have organic compounds is named through the International Union, also known as IUPAC, International Union of Pure and Applied Chemistry. This is a system of naming compounds according to their structural formula. And when we're talking about the structural formula, we have two types. We have the Kekulé structure and and we have the line structure. But on this channel, firstly, we'll be dealing on the Kekulé structure before we talk about the line structure. Now, before naming compounds, let's talk about the prefix and the suffix of the homologous series. Now, alkene and alkyne don't have any prefix. They just have the suffix. For alkene, we have in, alkene, we have in. They don't have any prefix. For alkanol, we have the hydroxyl. And for the suffix, we have the ol. For alkanoate, we just have the noate. They don't have any prefix. For alkanol, we have the on. They don't have any suffix for any prefix. For the alkanoic, we have the carboxylic. And we also have the oic as the suffix. While for the primary amine, we have the amino as the prefix, and we have the suffix amine. Then we have the al for the alkanal. Then alkyne also. Alkyne does not have any prefix, just the suffix ine. Now, this will help you to know the preference to give to the suffix in naming the compound. This is what I mean. Maybe if I have a compound containing, let's say, a double bond and an ol. If I have something like this, 1, 2, 3, 4, 1, 2. If I have a compound like this, now which of them will be the principal substituent? Which of them will be the principal substituent? Now, what is the substituent? A substituent are atoms or group of atoms other than hydrogen bond that is found on the parent hydrocarbon atom or chain. So this is a group of atoms. This is a radical. It is different from hydrogen bond, so this is a radical. And I also have another the functional group here in. So if you're having something like this, this is going to help you to know how to name this kind of compound. Firstly, I have 2 carbon. 2 carbon, I know it is what? 8. Now I also have a group here. This is a functional group carrying a double bond, which is from what? The alkene. So I have another parameter E. Now, and I also have what? The hydroxyl. So I can name this from anywhere. So I'll choose this to be my first carbon because it also contains a functional group. And if I name it, this becomes favoring the double bond because this is the first carbon. And it also contains, if I name from end to end, this is 1 and this is 2. If I also name here 1, 2, the both of them I can name from anywhere. But since this carbon is containing a functional group, hydroxyl, so this becomes my first carbon. So this is 1 hydroxyl because I have a principal substituent in. A double bond is greater than a single bond. So I will take the double bond to be the principal substituent. That means to be the suffix. So I have 1 hydroxyl. So this is 1 hydroxyl. Then I have, here is my 13 found. at 1-hydroxyl. Now look up, I use an hyphen to separate the number from the letters. So I have 1-hydroxyl at, where is my 18? Where is my 18 found? If I'm going like this, it's at the first carbon now. So this is 18, or I can say at 1 in, at 1 in, or 18. So this is 1-hydroxyl at 1 in. Now, why did I do it like this? Because I know that C don't have any prefix, while the alkanol has a prefix, so it can act as a prefix and also as a suffix. Now we have the rules for naming the compound. Number one is take the longest continuous carbon chain as the root hydrocarbon and name it according to the number of carbon atoms present, adding the appropriate suffix to indicate the principal substituent. Number two, number the root hydrocarbon from N, which gives the lowest number to the substituent. Now let's apply that to this compound. Well, we have this compound here. We have this compound here. Now let's use rule number 2 first. Okay, they say rule number 1, take the longest continuous carbon chain as the root hydrocarbon. So here we have 1, 2, 3. This is the longest continuous carbon chain. 3. Now, and they said name it according to the number of carbon atoms present, adding the appropriate suffix. Now let's go to rule number 2. Number the root hydrocarbon from N, which gives the lowest number to the substituent. So let's number this. We have 1, we have 2, we have 3, we have 1, we have 2, we have 3. Now, they said which gives the lowest number to the substituent. Where is the substituent? I said the substituent are atoms or group of atoms other than hydrogen that is attached to the parent hydrocarbon. Now, so if I have this 1, 2, 3, here I just have hydrogen, here I just have hydrogen, but here I have OH. This OH is like this, can also be written like this, and also have O. So this becomes, let's leave it like this. So this becomes the substituent. So this is the substituent because they are different from hydrogen bond. So this becomes what? My number 1. So I'll clean this. So I'm naming from here. Now look up. The next thing we have what? The functional group. We have the functional group. Rule number 5 says if there are 2 or more substituents. Rule number 3 in a compound, the number of these substituents are indicated by a prefix therefore 2. Now the remaining rules cannot be applied here because we don't have any other substituent again. So now look up. We have this functional group here. Where is this functional group coming from? This is from the alkanoate. So we have the noate. But the first thing we are going to do, I'm not telling you to do that. They say take the longest continuous carbon chain as a root and name it according to the number of carbon atoms present. So we have 1, 2, 3, right? So this is what? Pro. I will always tell you to bring out your parameters. Now, look up. For all this carbon, it has a single bond, except this functional group here, except this one. They all have what? A single bond. I will tell you to name it as propane because they all have what? Single bond. And we have the noate group. So this is the O8. O8. So when you bring out your parameters, are there anything to add again? No, there is nothing to add again. Now, sorry, this is the oic. Sorry, this is from the alkanoic. I'm sorry, oic. So There is nothing to add again. This COOH, this oik. Now let's see. I have propane because it contains single bond, but I also have another functional group, oik. Now if I want to name the alkanoic, I will name the alkanoic as I'm naming propane, but the E of this propane, I will change it to OIC, which is from the alkanoid. So I'll have propanoic. So the alkanoic, they are named by removing the last letter E from propane to IOC, which is the alkanoid. So I'll have propanoic. Now, for this one, this is the second one. So the first one is what? Propanoic. Now let's see for this one. I have NH2. Now this is the same thing as NH2. So you're seeing the functional group will be displayed on the screen. This is also the same thing as amine. Now look up. I have one carbon, and amine is attached to it. So if I want to name this, I have a functional group here. Since it is one carbon, I have a functional group here, a substituent here known as amine. But I gave you a preference. When you see amine has a preference, but oic has a double bond. Oic has a double bond compared to this man. So this, I'm going to call this, this is the oic. So this will be my amino, instead of me to use the prefix, sorry, I'll not use the suffix, I'm going to use the prefix. This is oic, and I have one carbon, met. So this is met. I told you the way to name the oic, the alkanoid, is you name methane first, if it is met, and remove the last E and add the oic. So I'll have metanoic. But I have amino here, so I'm going to change this. This is a prefix. I'll add it. I'll have something like amino metanoic. So this is the name for this compound. The second one is amino metanoic acid. This is an acid. Amino metanoic acid. Now, the next one, this is the same thing as this is double bond OH. This is the same thing as propanoic acid. This is the same thing as propanoic acid. Now let's look at this one. The last one, I hope I can clean. Our great compound. Now let's look at this one. Here I have the first thing. When you look at compound, first of all, try to get the functional group. This is this. I'm seeing the functional group. And where did I get this functional group? I gave you a functional group like this. So this is showing that it's from what? The alkanon. Alkanon, where I have C, a single C is double bonded to O. So you have this. Now, I'm not going to call this, normally, since this on is at the carbon, maybe I have a compound like, let's say if I have the same thing, like this, now this is a functional group. If I want to name this, I know that the carbon atom, if I use here, let me just make it false, so that it's going to be awesome. Okay, if I have something like this, 1, 2, 3, I have 1, 2, 3, 4, 5. So yeah, I have 1, 2, 3, 4. I have something like this. 1, 2, 3, 4. Now, if I want to name this kind of compound, I'm going to call this 1, 2. Now, you know that this is 1, this is 2, and this is 3, and this is 4. So I can call this 2 in because my in is at the second carbon, and boot because it is 4 carbons. So I can call this boot 2 in. This is telling you that my in is between what? The second carbon. But look up now. Look up. For this carbon, for this compound, my in, I can't say this is 2 on. Why? If I say this is 2 on, let me shift this compound. I hope I can clean this part. Let me shift this O to this part. If I say I have C, H, 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 then I have CH3. I have something like this. Now, if I shift this O and I take this one to this part, let's see. I shift this O from here and I take this other one here. I'm going to have something like CH2, which is alkanal. So, because of that, I'm not going to call this rather 2 in or something or 2 on. So, let's see. What is this compound going to be? I have 1, 2, 3 pro. Now, I will always call it propan because it has some single bonds. So, when you want to name compounds like alkanon, alkanoic, alkanoate, alkanoic and alkanon, especially, even with alkanal, you start with naming the compound as if it's an alkane, then remove the last E and add the functional group. So, if I have this 1, 2, 3, I'm going to have propan. Then this is O. This is from what? Alkanon. I'll have what? O-N. So if I add this O-N to this propane, I'll have propanon. So this is what? For this compound. Now, if you check, this functional group is at the second carbon. I didn't say propan 2 on because if I shift this to any of these, propan on exists between 3 carbon. You can't see it at the first carbon. It exists with compound more than 2 carbon because if it's at this side, it will turn to a compound alkanal or alkanoic, or if it's at this side, it can turn to any compound, but it exists from 3 compounds. Okay, so that's why we have propanol. Now let's go to the last compound here. Now, before you name a compound like this, please, if you have any question, let me see it on the comment section. I'll do well to reply your message. Now, but if you have a compound like this, the best way to answer this, if you're not good, you need to draw the structure first. So here I'll have CH3, which is for this. Here I'm going to have another C and H. Now look up. Now this CH3 here, I can't have a compound like this again because there is CH3 here. I can't have a compound like this again. So what this is telling me that this is a methyl anarchy group. So, and I have another CH, then I have Cl telling me this is what? Chlorine. Then what again? I have another C. Then I have another C. Then I have here methyl. Now there will be a double bond here. Cl, ClCC, right? Okay, after the Cl, this C. Okay, then we have C, 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 C. So we have C, C, C. So C and C again. That's 1, 1, 2, 3. 1, 2, 3. Then we have C, CHL. Then we have CH2. And we have C, then H3. Now, here I'll have the double bond, and probably there's supposed to be triple bonds. Okay, 1, let's see, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. There's supposed to be an H here. There's supposed to be an H there. Then this is what we have. Now let's see. The first thing. Now let's follow the rules now. We have take the longest continuous carbon chain as the root hydrocarbon. So this is the longest continuous carbon chain. So let's name this is the longest continuous carbon chain. So this is the root we are taking as the root hydrocarbon, and we name it according to the number of carbon atoms present. Now they said, so let's number it. We have 1, we have 2, we have 3, we have 4, we have 5, we have 6, 7, and 8. Then they said from end to end, so we number it again. 1, 2, 3, 4, 5, 6, 7, and 8. Now they said which gives the lowest number to the substituent. Now look up. I will tell you number 5. Now in selecting and numbering the longest continuous carbon chain, the functional group is preferred over the rest. That is, the functional group is giving the lowest possible number. Now look up. If we are naming from like this, let's see what's now. Look up. Here is a substituent. Here is a substituent. Here is a substituent, and here is also a substituent. Here is also a substituent, but this is a functional group. So I say the rule number 5: we select and number the longest continuous carbon chain. The functional group is preferred. That is, the functional group is giving the lowest number. So among all the substituents, is the functional group that is giving what? The lowest number. So if I want to do this, let's see. If I name 1, 2, 3, 4. Now I'm going like this. That is my my triple bond, which is preferred over the rest. We have what? The fourth what? Carbon, right? So if I'm coming from like this, let's see. 1, 2, 3, 4. That is also that my fourth carbon will take the double bond. So in either way I'm going, it's still the same thing, right? So I can number from anywhere. So I would like to start from left to right. But that right. So let's go. So if I'm naming this, I have 1, 2, 3, 4, 5, 6, 7, 8. Now let's see. 1, 2, 3, 4. I have fourth carbon, right? And this fourth carbon contains iron. So I will say 4 iron. This is a functional group. I'll take what? 4 iron. Let's see. 4 iron. Now let's see. I have 1, 2, 3, which is what? Chlorine. And I said if there are 2 or more substituents, okay. Now, if there are in a molecule, the substituents are named according to their alphabetical order. But where they are mixed substituents, the inorganic substituents are named first. By the prefix, we have chloro for chlorine. So if I'm naming this is what? Chloro. So I'll use the prefix chloro. But chloro. But look up, the chlorine is at where? The third carbon. I have 1, 2, I have methyl. This is also what? Methyl. So I have 2 and 6. My methyl is at where? The second carbon and what? The 6th carbon. So I will see this is 2. Now, if I'm separating numbers from numbers, I'm using a comma. While if I'm separating numbers from letters, I'll use an hyphen. So this is 2, 6, dimethyl. Why do I name it like this? Now look up. Rule number 3. If there are 2 or more substituents in the compound, the number of these substituents are indicated by a prefix di for 2. So I have 1 methyl there, 1 methyl there. So it is what? Di for what? 2. So I'm using dimethyl because the output is what? 2 methyl. And I said that the position of the substituent is given by what? A separate number. That means if you're naming a compound, the position of the substituent will be given what? A separate number, which is what? This 2 and what? This 6. So that's the position, that's where what? The substituent is being what? Found. So all of these numbers here, they indicate where the substituent are being what? Found. Now, is there any other substituent again? No. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is what? Oct. Indicating what? 8 carbon. Now, how am I going to name this? Look up. They said, now let's take rule number 2. Okay, rule number 3. If there are 2 or more substituents in the compound, the substituents are named according to their alphabetical order. But where they are mixed substituents, the inorganic substituents are named first. So if I want to name this, I will start with what? The inorganic substituent. So I'm going to have 3-chloro. The next one I will have 2,6 dimethyl, oct. Now look up. Before I continue, which of them is the principal substituent? Remember from rule number 1, take the longest continuous carbon chain as the root hydrocarbon and name it according to the number of carbon atoms present, adding the appropriate suffix to indicate the principal substituent. So if I'm naming this compound, which of them is the principal substituent? You know that this alkyne is what? The principal substituent. So I'm going to have oct 3-ine. So I can clean the rules. So I have it's 4-ine, oct 4-ine. So we have 3-chloro, 2,2-di, 2,6-dimethyl, oct 4-ine. Okay, so if you have any question, let me see it on the comment section.